Good morning. Today's topic in the chemical properties of alkenes. Markovnikov rule is completed. Next, anti-Markovnikov rule or peroxide effect or crash rule. First, Markovnikov rule means asymmetric alkenes upon treatment with asymmetric reagent like halogen acid or water or hypoalous acid. The negative addendum can attack least number of hydrogen containing carbon besides the double bond is called Markovnikov rule. Here, according to Markovnikov rule, propene upon treatment with HCl, it gives isopropyl chloride is a Markovnikov product. Normal propyl chloride is anti-Markovnikov product. Similarly, propene upon treatment with water, isopropyl alcohol is a Markovnikov product. Normal propyl alcohol is anti-Markovnikov product. Here, this anti-Markovnikov rule is carried out through free radical addition mechanism. Markovnikov addition is electrophilic addition. Anti-Markovnikov addition is free radical addition. It is carried out in the presence of hydrogen peroxide. Therefore, it is also called peroxide effect. Here, anti-Markovnikov rule is stated as asymmetric alkene upon treatment with asymmetric reagent in the presence of an organic peroxide. The negative addendum of radical attack at the more number of hydrogen containing carbon besides the double bond is called anti-Markovnikov rule or crash rule or peroxide effect. Once again, asymmetric alkene upon treatment with asymmetric reagent in the presence of organic peroxide, the negative addendum of radical attack at the more number of hydrogen containing carbon besides the double bond is called anti-Markovnikov rule. For example, propene. Here, that is propene upon treatment with HBr in the presence of organic peroxide. Here, this mechanism is carried out through free radical addition. It gives N-propyl bromide is obtained as a major product. It is called anti-Markovnikov product. In the mechanism, addition of HBr to propene in the presence of peroxide takes place by free radical mechanism. First one is formation of free radicals. Here, peroxide undergo homolytic cleavage to give, that is free radical, RO free radical. Here, this above free radical react with HBr to form bromine free radical. Here, that is RO free radical plus HBr. It gives ROH plus bromine radical. This bromine radical, first it can cleavage the double bond. It is homolytic cleavage. It is a smooth reaction. It attacks at the more stable secondary radical to give primary free radical. Here that is primary free radical, which is a unstable radical. But secondary free radical is more stable radical. Means here first bromide radical can attack at the more number of hydrogen containing carbon. By attacking the more number of hydrogen containing carbon, we will get the more stable secondary free radical is obtained as the intermediate product. In the third step, here The secondary free radical upon treatment with HPR. Again, this hydrogen radical can attacking at the secondary radical to give 1-bromopropane plus bromide radical is obtained as byproduct. Here it is the anti-Markovnikov rule or anti-Markovnikov product. Next, oxidation reactions of alkenes. Here first hydroxylation by Bayer's reagent. Alkaline potassium permanganate is called Bayer's reagent. When alkenes are passed into the alkaline solution of potassium permanganate solution, Bayer's reagent, two hydroxyl groups are added to the double bonded to form glycols, that is ethylene. Upon treatment with water with oxygen in the presence of alkaline KMnO4, it gives ethylene glycol, CH2OH, CH2OH, that is ethylene glycol. Similarly, propene, treatment with alkaline potassium permanganate, it gives propylene glycol, 1,2-dihydroxypropane is called propylene glycol. The mechanism, permanganate ion combines with a double bond to form a complex. This complex on hydrolysis to give ethylene glycol. For example, CH2 double bond CH2, ethylene plus permanganate ion, it gives a complex ion which undergo hydrolysis to give ethylene glycol. This is known as cis hydroxylation because the two hydroxyl groups are added at the double bond form same side. Means cis glycols are obtained. Second one is oxidation with paracids or epoxidation or peroxidation. Here ethylene oxide is obtained by direct air oxidation in presence of silver oxide, silver catalyst. It gives epoxide or ethylene oxide. Here CH2 double bond CH2 plus half O2 in the presence of silver catalyst, it gives CH2 CH2O. It is a epoxide or ethylene oxide. Other epoxides are prepared by action of paracids on alkene. An oxygen atom from paracid is added across the double bond to give an epoxide. This reaction is called epoxidation or peroxidation of alkene. For example, ethylene treatment with perbenzoic acid. This perbenzoic acid to give epoxide or epoxy ethane plus benzoic acid. Here mechanism is alkene ethylene plus RCOOH per acid. It gives epoxide plus acid. Just here adding the oxygen of double bonded carbon atom. Next, delocalization of oxygen bond to the carbon oxygen. 3 mole of proton. It gives epoxide and then acid, carboxylic acid is obtained as byproduct. Next, this oxidation. This oxidation, another one is oxidation with osmium tetroxide, OSO4. Here alkenes are oxidized by osmium tetroxide to give 1,2-dihydroxyalkanes at room temperature. This is also known as cis hydroxylation. Alkenes are oxidized by osmium tetroxide to give 1,2-dihydroxyalkane at room temperature. This is also known as cis hydroxylation. Here alkene plus osmium tetroxide, it gives the intermediate one. Treatment with sodium bisulfite to give, that is cis glycols. Seventh one is hydroboration, oxidation. Here diborane add readily at 0 to 25 degrees centigrade to the double bond of olefin to form trialkyl boranes. This reaction is known as hydroboration. For example, ethylene. Upon treatment with diborane, it gives triethyl borane. Equation is CH2 double bond CH2, 6 moles plus B2H6 at 25 degrees centigrade. It gives, that is ethyl triethyl borane, CH3 CH2B, CH2 CH3, CH2 CH3. In the case of an unsymmetrical olefin, the boron atom, positive part of BH3, the negative part is hydrogen. Add to the carbon atom having more number of hydrogen atoms, means Marconic of addition. Here CH3, CH2, CH double bond CH2 plus B2H6. The negative addendum can attack the least number of hydrogen containing carbon. That is, it gives tributyl borane. Here in the boration, it undergo Marconic of addition. Then end product is anti-Marconic of product. Here this trialkyl borane undergo hydrolysis to give, that is butyl alcohol is obtained. Means butene to butyl alcohol. Butene upon treatment with diborane undergo Marconic of addition to give tributyl borane. This tributyl borane undergo hydrolysis. It gives butyl alcohol, is a anti-Marconic product. Here in this process, synthesis of primary alcohols on oxidation with alkaline hydrogen peroxide, trialkyl boranes are converted into a primary alcohol. Here that is tributyl borane. Treatment with peroxide. Normal hydrolysis to give alkanes, but treatment with peroxide, it gives anti-Marconic product of normal butyl alcohol is obtained. Next, this hydroboration oxidation process gives the anti-Marconic hydration. Addition of water on the double bond. Again a regioselective reaction, that is propene. Action with diborane, it undergo Marconic addition to give tripropyl borane. Upon treatment with hydrogen peroxide in the presence of alkali, it gives propyl alcohol, is a anti-Marconic product. Next, synthesis of alkanes. Here, hydrolysis of trialkyl boranes with aqueous acid yield alkanes, and thus hydroboration provided a method for the conversion of alkene to alkanes without using hydrogen and metal catalyst. Here this is tributyl borane undergo hydrolysis to give N-butane plus boric acid is the byproduct. Eighth one, it is important one, ozonolysis, addition of ozone. Ozonolysis means the process of addition of ozone to the double or triple bonded unsaturated hydrocarbon to give intermediate ozonide, which is subjected to hydrolysis to give carbonyl compounds, is called ozonolysis. Once again, the addition of ozone to the double or triple bonded unsaturated hydrocarbons to give intermediate ozonides, which upon treatment with water in the presence of zinc, it gives carbonyl compounds, is called ozonolysis. Example, ethylene plus ozone, it gives ozonide of ethane. These undergo hydrolysis to give 2 moles of formaldehyde plus hydrogen peroxide. Similarly, then propene plus ozone. It gives ozonide of propane. Upon treatment with water in the presence of zinc, it gives two types of carbonyl compounds. One is acetaldehyde, another one is formaldehyde with hydrogen peroxide is obtained as byproduct. With this, alkenes is over. Next, alkadiens is in the next class.